Hello guys, today we are going to actually build and simulate a LED series circuit. There will be simulation and actual hardware testing. So first, let's go to Multisim. I'm going to select the LED light. I will copy the LED light multiple times. And let's choose the colors that I want for my LEDs. The yellow LED, the green LED, the red LED, and finally the blue LED. I will choose a DC voltage source and set it up for 12 volts and connect all the LEDs in series with the limiting resistor, the switch or push button, and the voltage source. The green, blue, and purple probes are measuring the current, because we will see that this circuit has the same current for all. Pay attention to the value of the current that the probes are measuring. Now run the simulation. I close the switch or the push button, and you see that every time that I close the circuit, all my LEDs light up and the current is the same at all points because we have the same current flowing through this series circuit. Now let's go to practice with a hands-on experiment. We have 14.8 kilo ohms. Let's connect the resistor to the breadboard. Let's do a bridge from the resistor to the button. We are going to build a button control circuit. So this is the button right here. Then we have a bridge from the resistor to this node. We have the yellow diode or LED, a bridge to the next LED, the green LED. We have other bridge to connect the green LED to the red one in series. Remember guys, we are doing a series connection. And we have this connection that goes to this node. I'm going to measure the potential difference across the source. I am going to use this source. This is about 4.6 volts. Let's connect the source to the breadboard. Black is ground. So let's take the ground to the switch. And let's take power, the red one. I can power the switch right here. Let's see if it works. No, it didn't work. Why? Maybe it's that this DC source is not enough to overcome the series potential barrier of all the diodes. So we need to build a higher source. I'm going to hook multiple batteries together. So let's see. This should be 9 volts, but because it's an old battery, it's only 6.3. It's 1.5. This is 1.5 volts. I'm going to add those batteries together to create a higher potential. So I'm going to put this here. So this is going to be connected through this white wire. I'm going to connect like this. Now that they are connected in series, they should add together. Let's see. Test source. So to the plus, to the minus, and I will hook the ground to the minus with the multimeter in parallel, and let's hook the plus. So you see guys, we get 12 volts. We have a higher potential now. So let's use this new source to power up our circuit. I'm going to take out the testing probe. Let's see if it works. Yes guys, it works. All the diodes light up. Let's put one more diode to see what happens. So let's see. I'm connected to one diode, one more diode or LED, and let's see what happens. You see guys, they all light up. What happens if I take this diode and connect it in the opposite way? You see, I just turn the direction. Let's see what happens. It doesn't work. You see guys? So the series connection is not working. It's open circuit. Let's turn again. You see, I just turn the diode again to the initial position, and all the lights are working because all of the diodes are correctly polarized. If I take any diode and turn the direction in the wrong way, the whole connection is not going to work because this is a series connection and they share the same current. This is the circuit's close-up. Now let's go to the Multisim simulation. The probes in this circuit are measuring the current. Pay attention to the value of the current at different points in this circuit. You see that when I close the circuit, all the diodes light up and we have the same current around the whole circuit. Now let's see what happens if I change the direction. I change LED 1 to the opposite direction. And we see that when I close the circuit, there is no current. All the diodes are off. Now let's back to the original position. And you see that now that all the diodes are correctly polarized, there is current through the circuit and all the diodes light up. Let's measure the potential difference across each diode. I'm going to measure the yellow. Let's see. You see guys, it's 1.7, the yellow. Now let's see the green. This is positive, this is ground. We get 2.1, almost 2.2 guys, for the potential difference across the green diode. Let's see the potential across the red diode. It's 1.7 volts guys. And the potential difference across the blue diode is 2.5 volts. We saw that each LED has a different potential difference across its terminals. This is related to the potential barrier of each diode, depending on its color and semiconductor physical composition. Now let's see the potential difference across the resistor. And let's put the ground here. We want to know what's the potential difference across the resistor. We get 2.4 volts. And now let's measure the potential difference across the source. And across the source, we have 10.6 volts around. And across the source, we have 10.67 volts. So if we add the potential difference across all diodes plus the resistor, we should get a number really close to this one because of the Kirchhoff voltage law. This is a voltage divider, and each diode has a potential difference according to its potential barrier. The resistor is going to accommodate to what's happening with the diodes, with the circuit. And the addition of all the potential differences has to add to the potential across the source. Thank you for watching, guys. I hope that this was useful. Remember to comment, like, and share with your friends. I'll see you in the next video. Bye, guys.